Welcome to solverfy.
In this question, we want to find what is the ratio of the velocity between the molecules UF6, where U is uranium-235 versus U is uranium-238. Now we are assuming that the temperature that they are at is the same, right? Then by the equation, right, by the equipartition theorem, the kinetic energy must be the same, right? Which is equals to 3/2 kBT. So they must have the same kinetic energy at the same temperature. And with the same kinetic energy, they must have the same half mv square. Right? This is the expression for kinetic energy. So that would mean if we take half mv square of uranium-238 times the velocity of uranium-238 squared, divide that by half uranium-235 times velocity of uranium-235. Now this I'm referring to all the molecules of UF6, right? Not the nuclei themselves, right? So just to avoid confusion, we should get a value of 1 since they have the same kinetic energy. Right, in order to get the ratio for the velocity, then in this case, we need to bring the ratio of the masses across. Alright, so what we need to do now is to divide over. We can divide the masses or divide the velocity. I'm going to divide the velocity across, right, since we are more concerned with the velocity. So this uranium-235 over velocity of uranium-238, right, brought over to the right hand side, and then we take the square root of both sides. We should get square root of mass of the molecule containing uranium-238 divided by the molecule mass of the molecule containing uranium-235. Right, so the ratio of the velocities are now related to the mass of the various molecules. So all we have to do now is to substitute in the mass of the molecules. You can use atomic mass. So that's 238.05 plus 6 times 19. Right, so that's the atomic mass for the fluorine. It's 235.04 plus 6 times 19. Alright, and we should get a value of 1.0043. And so the ratio of the molecule, velocity of the molecule containing 235 to velocity of the molecule containing 238 is 1.0043 is to 1. So slightly faster, right, because of its mass.